Dear students, under the topic center of mass, now here we are going to use the method of integration and we are going to find the center of mass of a thin wire in the form of a circular arc. So now here we consider a thin wire which is in the form of a circular arc and the arc is taken as AB. Now we are going to find the center of mass for this thin wire. The formula for the center of mass is given by, represented by OG vector, is equal to integral x dm divided by capital M. Now what is this x? X is the coordinate along the x-axis as we have taken the thin wire symmetrical about the x-axis. And dm is the mass of the little portion, that is the elementary portion that we will be considering into account, and we will be integrating it in order to find the complete center of mass, divided by capital M, where capital M is the mass of the thin wire that we have taken. So therefore dm is the mass of the elementary portion of the wire and capital M represents the total mass of the thin wire that we have taken. Now in order to find the center of mass, we first need to find capital M and dm and then substitute in this formula. So let us do that now. For this we have to make certain assumptions which are given as follows. So let us make the following assumption. First of all, let us consider A to be the radius of the circle. So we have taken A to be the radius of the circle which we will be obtaining from this circular arc. So therefore the radius has been taken as A. The next assumption is 2 alpha is taken as the angle subtended by the wire at the center O. So the angle of suspension of the thin wire at the center O is taken as 2 alpha. And then the next assumption is OC, the line OC, which is the middle radius, and this is chosen as the x-axis. And then we have capital P, which is a point on the wire. So if you see in this diagram, so capital P is a point on this wire. So this is the next assumption. And then we have xy, which is the Cartesian coordinate of the P that we have taken on the wire. So x comma y is the Cartesian coordinate. And similarly, r comma theta is the polar coordinate of the point P. So x comma y is the Cartesian coordinate and r comma theta is the polar coordinate. And in that case, x will be equal to r cos theta, that is x will be equal to r cos theta and y will be equal to r sin theta. And then we have P dash, which is another point on the wire. So if you see, first we chose the point P and now here we have the point P dash, which is another point that we take on this wire. And therefore this PP dash will be an elementary length. So PP dash will be the elementary length of the wire, which means a little portion of the wire that we have taken. So I have written that here. So PP dash is elementary length of the wire. And then we have theta and delta theta. What is theta? Theta is the angle subtended by PC at O. And delta theta is the angle subtended by PP dash at O. That is, if you see here we have theta. And it is the angle subtended by this portion of the curve, that is PC. Okay. So the angle subtended by PC at the point O is theta. And what about delta theta? It is the angle subtended by this portion of the curve, that is PP dash. So the angle subtended by PP dash at the point O is delta theta, which is a minute change in the angle theta, since PP dash is a very elementary portion that we have considered. And then we make a final assumption lambda, which is taken as the mass of the wire per unit length, That is, for 1 unit of length, the mass of the wire is taken as lambda for only 1 unit of length of the wire. So the mass taken is lambda. So therefore these are the 4 assumptions that we have made. So after these assumptions, next we will calculate the mass of the circular wire. That is, we are going to calculate this capital M, which we will be using in this formula. So let us calculate the total mass of the circular wire. And we have taken, and remember, we have taken the mass of the wire per unit length. That is, for 1 unit length, the mass of the wire is taken as lambda. With the help of all this data, now we have to calculate the total mass of the circular wire. So let us see how to do that. Now in order to find the total mass of the circular wire, if we find the total length of the wire, we can find the total mass of the circular wire. This is because we know that for unit length, the mass of the wire is lambda. For unit length, if it is lambda, then if we multiply that lambda with the total length of the circular wire, we will get the total mass of the circular wire. So therefore, in order to find the mass of the circular wire, first we shall find the total length of the wire. How to calculate it? So the total length of the wire is equal to what? The circumference of the wire. So how can we calculate the circumference of the wire? We have to multiply the radius of the circular wire and the angle subtended by the wire at the center O. And so therefore that is equal to radius of the circular wire multiplied with angle subtended by the wire at the center O. So what is the radius of the circular wire? So from our assumption, we know that the radius of the circular wire is A. So it is A. And then we need the angle subtended by the wire at the center O. So what is the angle subtended by the wire at the center O? It is 2 alpha. So we have to multiply A and 2 alpha. So this is equal to, so the radius is A multiplied with the angle subtended by the wire is 2 alpha. So therefore the total length of the wire is equal to what? 2 alpha multiplied with A. So let us mark this as 1, because we will be making use of this while finding the mass of the wire. So the next step is we have to find the mass of the circular wire. So how to find that? We have to multiply this total length with the mass of the wire per unit length, which is lambda. So let us do that now. So therefore the mass of the circular wire is equal to total length of the wire that we have found, that is from 1, multiplied with the mass of the wire per unit length, which is lambda by our assumption. So if you check out here, you have it here. That is lambda is the mass of the wire per unit length. So let us substitute these two values over here and we will find the mass of the circular wire. So therefore the mass of the circular wire is represented as capital M, and that is equal to the total length is what? 2 alpha A. And this is multiplied with mass per unit length, which is lambda. And so therefore capital M is equal to 2 alpha lambda into A. So this is the value of capital M. Let us mark this as 2. Okay. So we have got the value of capital M, which has to be substituted while finding the center of mass. Now next we have to find the value of dm, which is the minute mass of the elementary portion pp dash. So now due to the symmetry of the wire about the x-axis, that is OC, the mass center G of the wire lies on OC. So this is OC and somewhere here on this line the mass center capital G lies. This is because due to the symmetry of the circular wire about the x-axis, which is taken as OC. Therefore the mass center lies on this line. Anyway, now in order to find the value of dm, which we require to find the mass center, what we will do is we will find the length of pp dash, that is the elementary portion, because we know that the mass per unit length is lambda. So we want to find the mass for pp dash. So now in order to find the mass for pp dash, we will first find the length of pp dash. And then when the length is multiplied with the mass per unit length, we get the total mass of pp dash of this elementary portion. So let us do that now to find dm, the value of dm. So the length of pp dash is given by the radius of the circle multiplied with the angle subtended by pp dash at O. So from assumption, we know that the radius of the circle is A and the angle subtended by pp dash at O is delta theta. That is, the radius of the circle is A and the angle subtended by pp dash at O is delta theta. So when we make this substitution over here, we get this to be equal to, so the radius is A multiplied with the angle subtended is delta theta, and therefore the length of pp dash is A delta theta. Next we shall find the mass of the elementary length pp dash of the wire. So the mass of the elementary length, that is pp dash of the wire, is equal to length of pp dash multiplied with mass per unit length. So we know that the length of pp dash is what? Just now we have calculated it to be A delta theta, and this has to be multiplied with mass per unit length, which is lambda from our assumption. So that is equal to, so finally what we get? A lambda delta theta. So therefore the value of dm we have found, and that is equal to A lambda delta theta. So we have the value of capital M already, just now we have found it, and the value of dm also. Now we will take those two values and substitute in the formula for center of mass. And also we have to make a note of this, that its x coordinate is given by x equal to a cos theta, where theta lies between negative alpha and positive alpha. We shall now make use of this and we shall find the center of mass, which is given by OG, and that is equal to integral x dm divided by capital M, and that is equal to integral, we know that the integral varies from negative alpha to positive alpha. So minus alpha to plus alpha, and the value of x is what? A cos theta. And what is the value of dm? The value of dm is A lambda delta theta. So we have to make this substitution. So A lambda delta theta. So A lambda, and delta theta, when it goes inside the integral, it becomes d theta divided by, so remember, whenever we take delta theta within the integral, it becomes d theta divided by capital M. And what is capital M? We got capital M as 2 alpha lambda A. So we shall substitute that. So 2 alpha lambda A. Now we shall check, are we able to cancel the terms? Yes, we are able to cancel the A over here, one of the lambda over here. And this integral will be equal to, this A is a constant which can be taken out of the integral. So A integral negative alpha to positive alpha cos theta d theta, the whole divided by, in the denominator we have 2 alpha. So 2 alpha, and this is equal to A divided by 2 alpha. And what is the integral of cos theta? We know that cos theta, when integrated, it becomes sin theta, and between the limits minus alpha to plus alpha. This is what we have, and that is further equal to A by 2 alpha, substituting the upper limit and the lower limit. So first upper limit in the place of theta. So sin alpha minus the lower limit minus sine of minus alpha. But what is sine of negative angle? Sine of minus alpha is equal to minus sine alpha. This is from trigonometric identity. So using this identity, we get this to be equal to A by 2 alpha multiplied with sine alpha, and sine of minus alpha is minus sine alpha. So minus and minus gets multiplied and it becomes plus sine alpha. And what is sine alpha plus sine alpha? 2 sine alpha. So that's equal to A by 2 alpha multiplied with 2 sine alpha. So the 2 and 2 gets cancelled, and therefore this is equal to A sine alpha divided by alpha. So this is the answer, that is the center of mass for the thin wire in the form of a circular arc. So hope you have understood how to find the center of mass for a thin wire in the form of a circular arc. Now next we have a small corollary by using this. So when the wire is a semicircular wire, the value of alpha will be equal to pi by 2. So if alpha is pi by 2, what about OG? It will be equal to A sine alpha is pi by 2. So A sine pi by 2 divided by pi by 2. And that is equal to, what is sine pi by 2? It is sine 90, and that is 1 divided by pi by 2, and the denominator of the denominator becomes the numerator. So this 2 which is in the denominator of the denominator becomes 2a divided by pi, and therefore the center of mass for a wire in the semicircular form is given by 2a by pi. This may come under 1 marks, so kindly make note of it. So hope you have understood the complete problem of finding center of mass of a thin wire in the form of a circular arc. So in our next video, we will be finding the center of mass for a solid hemisphere. Thank you.